cheetah. How fast do you think the cheetah goes? Yeah. Okay, let's draw a line. Cheetah. Okay. How about the lion? How fast would you guess the lion goes? What? Finn? Oh, well, that's too bad. Alex? Yeah, that's correct. 80 kilometers per hour. How about the hippo? Tyler?
30 kilometers per hour. Or no, 40.
40. Hippo can go 40. Okay. How about the whale? Bastion?
Is it 5?
No. Carly? Yeah, it can actually go a little bit faster, but
8 to 5.
okay. How about the tortoise? This is hilarious. We did totally do that backwards on that last slide. Okay, how about the tortoise? How fast does it go? Kala? Centimeters per minute? No, it can go faster than that. Anthony? 5.8 centimeters per second. Okay, and then how about the snail? Yes. Okay, that gives us a kind of a better pulse on these.
5 centimeters per second.
Okay. All right, what we're gonna do today, we're going to be figuring out some rates and we're gonna be practicing showing our work properly. So we'll have a couple different tools we can use. The way that I show you first. We'll also be using like 3-step methods, like where 3 steps where we have a formula, substitute and solve, but we're gonna start off with unitary. All right, so a printer took 3 minutes to print out a 120-page document. How many pages can it print in 1 minute? All right. Do you guys have this in your notes already? Okay. So here's what we want to do, you guys. When we set this up, we want to put what the value that we're trying to find. So whatever quantity we're finding goes on the right. Okay. So your first line looks like this. 3 minutes and then arrow 120 pages. So 120 pages per 3 minutes. Okay, we're on the first slide. Can you guys see it? Underneath method 1 on that first slide. You do. Yeah, you guys, you have it. It's right here. See where it says work? That's what you're copying down. Oh. Okay, so you're going to copy down what you see under work. Finn? But I'm not ready for an answer at this point. I'm demonstrating how to show work and how to properly do the problem. Okay, then we're going to take it down to 1 minute. So we'll divide both sides by 3. What is 120 divided by 3? Finn, please don't scribble those out. Please copy work so that you know how to show work on quizzes, tests, and homeworks and all the things. 120 divided by 3. Anthony. Good. All right, so in 1 minute, we can print 40 pages. All right, is that our answer? Yes. Yes. Says how many pages can it print in 1 minute? All right, now we want to know how many minutes it will take to print a 200-page document. Just a second ago, do you remember what I said about what value we put on the left and what value we put on the right? Yes. Okay, so what are we trying to find right now? A time or a number of pages? What? No, we're just trying to find a time. So time now, we're going to flip-flop the arrow diagram is going to go on the right because we're trying to find a time. So we're going to put 40 pages on the left. And then the arrow means equals or in 1 minute. Okay. So this is under that work section on the second part of the problem, guys. So you're copying this down. All right, now we want to go from 40 to 200. What's our multiplier? Oops. What's our multiplier, Tyler?
5.
Yes, 5. Good job. So we're multiplying both sides by 5. And it's going to take us 5 minutes to print a 200-page document. All right, so on these arrow diagrams with rate, it can be confusing because we can put like either value on either side, and depending on the type of problem, we're gonna decide which thing we need to put where. So again, what goes on the right side? What goes on the right? The thing we're trying to what? The thing we're trying to find. Yeah. So whatever quantity we're searching for goes on the right. Yeah. No. Sorry. It's like asking me if you can spell things differently than the way they're supposed to be spelled. So, no. Because it's an arrow diagram. So we're going to use an arrow in the arrow diagram. Yes. Nope, we're going to use arrow diagrams. Okay. All right. So I think we answered this question, but let's just recap it. Why did we reverse the sides of minutes and paper? Why did we need to reverse those, Ray? Yes, exactly. Great job. Okay. All right. So here's another method. Another method is to use a table. So same problem, a printer takes 3 minutes to print out a 120-page document. So if we wanted to, we could, and we know how many pages it takes and it prints in 1 page, or 1 minute, excuse me, but we could just make a table. In 3 minutes, if it prints 120 pages, we could divide 120 by 3 to get what it prints in 1 minute. And then we are just counting up by 40 every time we go up in our table. So in 2 minutes, it's going to print 80 pages. And in 4 minutes, it's going to print 160. And in 5, it's going to print 200. So that's another tool for your tool belt. Okay. Okay. So cross off that next slide. The one that says a printer took 3 minutes. So we're not going to go over a third method. Just that one slide where it says a printer took 3 minutes, that the same problem again. We're not going to do that again. Okay, so let's find another rate. This time we're going to be finding the rate of bottle caps in 1 minute. Okay, in a factory, a machine caps 70 bottles in 1 minute. At this rate, how many bottles does it cap in 5 minutes? What do I want to put on the left and what do I want to put on the right? Elijah? Yeah, exactly. So 1 minute. Now we're going to keep our units consistent, guys. Okay. So when we do this, we're going to add the minute and the bottles and all the things. It's going to really work well to keep our things straight. So in 1 minute, the caps 70 bottles. I want to find out how many it caps in 5 minutes. So now what? Kala? Yep. 70 times 5? Yep. So our multiplier is 5. So we do that to both sides. So in 5 minutes, how many bottles are going to get capped? 350 bottles. Great job. At this rate, how many bottles does it cap in 1 hour? Now what do I have to do? Elijah? Yes. Let's do, oh, it already says that. Oh, okay. So I guess we can multiply by 60, or we could do some in-between mental math. We could multiply by 10. In 10 minutes, how many bottles will be capped? 700. And so, and then we can add, or we can multiply that by 6. So can we multiply 700 times 6 pretty easily?
Yep.
Okay, what's the answer? 4,200. Good. Bottles. Okay. All right. car required 1 gallon of gasoline to travel 25 miles. At this rate, find the amount of gasoline required to travel 1 mile.
We're dividing them.
Well, hold on. Let's talk about how to set it up. How do we set it up? What goes on the right and what goes on the left? What value are we trying to find? Gasoline or miles? Let's read it. Let's read it carefully. At this rate, find the amount of gasoline required to travel 1 mile. So Annie, what am I trying to find? Gasoline or mile? Gasoline, great. So what goes on the right? What is it? Gasoline goes on the right. And it's in terms of gallons. So gallons is our unit, not gas. And then miles is going to go on the left. So 25 miles is required for 1 gallon. So that's what our arrow diagram looks like to start. Okay, now what do I need to do to get from 25 to 1? Mateo. Yep, we're going to divide each side by 25. Okay. Is everybody understanding why we're putting one thing on the left and why we're putting something else on the right? Pretty clear? Elijah?
Oh, I need to give you some.
Oh, did I just say that right? Well, I said, my question was, are you understanding which value we put on the right and which value we put on the left?
Yes.
Okay. Oh, okay. So, how many gallons are required for 1 mile? I'm hearing a lot of answers. Well, how about we keep it in a fraction? Since we're just dividing a 1 by 25, what's the answer? 1/25th, yeah, 1/25th. There is no need to do unnecessary division. We can just keep it as a fraction. I don't require decimals most of the time. Sometimes we do, but yeah, but it's extra work, so just don't. Actually, I'm going to tell you in this unit, we're mostly just going to use fractions because we'll be doing so much cross canceling, and then like unitary method, it's just way easier to keep it as a fraction. Annie?
When we're showing our work in our notebook,
Yeah.
are we gonna after we get it, write it out and then
You should,
box it?
you can just box it. Just make sure you have the unit with it. Maddie? Yeah,
Like,
it's kind of like precipitation, like rain. Okay, so let's just do it. Yeah, it's not super important that we like really comprehend like sprinklers and precipitation for this problem, but it is important that we comprehend the rate. So at this rate, find the amount of water it sprays in 1 hour. What am I trying to find? Amount of water or time? Water. So what goes on the right of my arrow diagram? Water. Okay, so let's go ahead and set it up. Tell me how to set this up from left to right. What do you think? Go ahead, Annie. Okay, we just talked about the amount of water being the value we're trying to find.
4 hours in the period.
Yep, 4 hours. In 4 hours, it sprays 6 inches. Good. All right. What are we trying to find? We want to find out the amount of per hour. So what do? Ainsley. I divide both of them by 4. Okay, good job. So that's going to give me, so let's divide both by 4. Keep it as a fraction, you guys. So what do I get? In 1 hour, the sprinkler sprays how many inches? Go ahead, Ainsley. 1 1/2. Great job. All right, so in your textbook on page 126, I'd like you to do numbers 3 and 4, please. All right, so number 3, it says a tap fills a 500 centimeter or cubic centimeter beaker at a rate of 20 cubic centimeters in 1 second. At this rate, how long does it take to fill the beaker to the brim? So you guys already had the arrow diagram set up for you in your textbook, but hopefully even without looking at it, you would have known I've got to put time on the right because time is the value that I'm trying to find. Okay, Nora, what'd you do? Cubed.
Cube,
Uh-huh,
is 1 second, so 1 centimeter cubed is 1/20 a second.
nice.
1/20 times 5 to the 1, which equals 50/2.
Nice job. Which equals 25 seconds. Okay. All right, how about number 4? So number 4 said a photocopier makes 400 copies in 5 minutes. At this rate, how many copies does it make in 1 minute? Charlie,
So 5 minutes equals 400 copies.
yeah. So
5 divided by 5.
great job. So you divided both sides by 5 and you found that it makes 80 copies. All right, I'm going to show you another way to write this. Okay, when we are talking about rate and speed, often things are written in special units. So rates are units where you're comparing one type of thing to another type of thing, and it's often with the word per. So let's talk about how we would write 20 or what is it? 20 centimeters cubed per second. So if we were to talk about the rate at which the water is being filled, so 20 centimeters cubed in 1 second. Now this isn't our answer, but 20 centimeters cubed per second is how that would look. So I don't know if you guys remember that I've shared with you that the fraction bar can be read as per. Means the same thing as divide, well, percent, right? Yeah, so percent. So this is what our rate label looks like. So we will use labels and rates. And in this particular problem, if we were to ask, if you were to say what's the rate of water flow, it would be 20 centimeters cubed per second. Over here in number 4, what's the rate that copies are being made in per minute? Per minute. Charlie? Yeah, 80 copies per minute. Now we don't write the 80 over 1, but literally what it means is 80 over 1 and 20 centimeters cubed over 1 second, 80 copies over 1 minute. But we don't ever write that over 1. We just assume it with the rate value. So this is the same as, or the, you'll usually see speed units written like miles per hour, side to side like that. I don't like to have you guys write your rates horizontally, because we will actually end up cross-canceling units as well as numbers. And so it's just going to be a lot easier to have them be written vertically. Yeah.
So if we have homework tonight,
If we have homework,
I'm asking.
you mean hypothetically, if you had homework in math, should you show your work correctly like the lesson just demonstrated? If you have an answer where you're giving a rate, then yes, but no, I'm just showing you how we would write this particular rate. I think on your homework tonight, you're going to just be finding values on either side of the arrow diagram. So for example, that's not your homework, but I don't know. I can't think of one, but I just looked at it like a minute ago. Yeah, it's workbook exercise 1. So you will show arrow diagrams for all of these problems. So, for example, number 1, the question is it says a machine fills 150 cartons of orange juice in 5 minutes. At this rate, how many cartons of orange juice does it fill in 1 minute? So you're just looking for a time value. So there's no rate to write. It's just a time value. So your unit is going to be a minute. Does that make sense? Okay, cool. You guys can go ahead and get started.